In this lesson, we will be reviewing measures of central tendency. You have learned about these in previous math classes. The mean, median, and mode are called measures of central tendency because they give us an idea of where the middle or center of our data tends to be. Remember that the mean is what we think of as the average, as in the average teacher is mean. We denote the mean as X bar. It's just a big capital X with a bar above it. When you see this symbol, you know you need to add the values and divide by the number of pieces of data. One disadvantage of the mean is that it is strongly affected by extreme values. In a class of 10, if 9 people get 100 and the 10th person gets a 0, the mean becomes a 90%, which is not truly representative of the average grade. Complete the example and check your solution. Be sure to pause the podcast. In this problem, because we had 5 pieces of data, we added them together and divided by 5 for a mean of 14.2. One thing new for you to become accustomed to is sigma, or summation notation. This is a notation used in mathematics to do one of the following: either add the values in a list of numbers or apply a formula to a set of numbers and then add them. Sigma is the Greek letter sigma or S, and it stands for sum in this notation. In our first example, it is telling us to add items from a set of data. We are looking at the sum for I equals 1 to 5 of x sub I. It says add the items from the first to the last in the set of numbers named x. This part over here is called the index, and it tells you where to start and where to finish. So in this particular problem, we would simply add 2 plus 3 plus 5 plus 8 plus 10, and that would be our solution. 5, 10, 18, 28 would be the sum of those numbers. Now, in the next example, we are going to be using it to apply a formula. To do this, we'll write the problem in what we call expanded form and then evaluate it. In this problem, our index says we are going to use values of n, and these are always integer values from 1 to 5. We're going to fill them into the formula of n minus 1. So in expanded notation, that means we're going to do 1 minus 1, and then the summation or sigma notation tells us to add that to 2 minus 1 plus 3 minus 1 plus 4 minus 1 plus 5 minus 1. That would be our expanded notation. Now, when we finish it, all we simply do is we go ahead and we add those numbers up. So that's 0 plus 1 plus 2 plus 3 plus 4, or 10. Now you try the practice problem. Pause the podcast, work, and then check your solution. Hopefully you got solution of 30. Now we're going to look at the summation notation formula for the arithmetic mean. It looks a lot scarier than it really is. This portion of it, with the sigma notation I equals 1 to n, just means add up the numbers, or the data pieces. And the 1 over n is simply saying divide by the number of pieces. However, this is the notation you will see on the formula sheet that you receive with your test, and this is the notation that you'll be seeing in the future. The next measure of central tendency is the median, and the most important detail about the median is that you have to have the data in rank order. Now, rank order simply means going from small to large or large to small. If there happen to end up being 2 numbers in the middle, you need to average them. There are actually 2 options you can use for finding the median. You can take your list of numbers once they're in rank order. These numbers you can go ahead and copy down. Notice they are in order. If you have a small number of pieces of data, you can simply knock them off, one at the beginning and end, until you end up with a number left in the middle. Oops, there were two numbers left in the middle, so I have to add them and average. And 11 plus 13 is 24 divided by 2. So in this case, my median would be 12. The other technique which you use if there are a large number of pieces of data is to know how many pieces of data you have and then find the position that they're between, that the median will be between. In this particular case, I had 8 pieces of data. 8 divided by 2 is 4. Since 4 had no remainder, that means there's not going to be a number left in the middle, so I know my median is between the 4th and 5th positions in my data, which was between 11 and 13, making the actual median be 12. The mode is simply the number that happens the most frequently. And you can have data sets that have no mode, everything is only used once, or you can have data sets that have 2 modes, which would be bimodal, or even more than 2 modes. Now here's an example problem. I'd like you to go ahead and try it on your own. You're supposed to find the mean, the median, and the mode, and then decide which measure of central tendency best represents the data. You should be able to come up with a reason for this. Go ahead and pause your podcast and try the problem. You can see I used the summation formula. I did 1 over n times the sum of the numbers from the 1st to the 12th of the numbers in the data set. That sum was 542. 1/12 of 542 was 45.2 for the mean. There were 12 pieces of data, so I divided 12 by 2 and got 6. So the median was between the 6th and 7th piece of data. The 6th piece of data was 46. The 7th piece of data was 47. Halfway in between there was 46.5, so that was my median. And the mode was the number that happened most frequently, which was 46. It did not matter that 54 was repeated. The only thing that was important was that 46 happened the most often. Now on this problem, the mean, the median, the mode were all very close together. However, if you look at the data, you will notice that one piece of data is pretty far off the others, and that's the first piece where it was 11 home runs. That means that the mean has probably been skewed, so the best measures of central tendency would be either the median or the mode. Either one are very close to one another. That shows that they're very, very similar. The next thing we're going to look at is a stem and leaf plot. And a stem and leaf plot is something that you use to organize a lot or large amount of data. The stem is the left-hand column, and it's the most common place value of the data. The stem can be more than one digit. It can be the hundreds digit, it could be the hundreds and the tens digit, it could be the tens digit, it could be the ones digit, and then the leaf could be the decimals. The key to the stem and leaf plot is that the leaf will always be a 1-digit number. You never include a decimal point in a stem and leaf plot. You show that by having a key that goes with it if there are decimals involved. Anytime you do a stem and leaf plot, there will be a key that goes with it that shows how the numbers are read. Now what we're going to do is take this data and organize it into a stem and leaf plot. Since all of the numbers are between 10 and 50, I only need tens digits for my stems, so I'm going to start with my stems, which are going to be 10, 20, 30, 40, and 50. And then I'm going to add on my leaves, which are going to be the ones digits. Now, I'm going to start with the very first number, and when I do it, I usually do the stem and leaf plot twice. I do it once just to get the stems and all the leaves together, and then I reorganize the leaves to actually go in rank order. So my first number was 42. I put a 2 next to the 4. The next number was 49. I put a 9 next to the 2. No comma, no decimal, anything like that. It's just the next number over. So the two numbers there would be read 42 and 49. The next one was 36, then 32, then 10, 19. Continue on with this on your own and then check your final stem and leaf plot against mine. This is the rough draft of my stem and leaf plot. The next thing I would do is go ahead and rewrite it, getting the numbers in correct order, getting my leaves in the correct order. On the right you can see my completed stem and leaf plot. At this point I could find the mean, the median, the mode, everything strictly from the stem and leaf plot. I would have to know for the mean that the numbers are 10, 19, and so on. To find the median, I need to know how many numbers there are. So there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 25 pieces of data. So 25 divided by 2 is 12 with a remainder of 1. That means the 13th piece of data is my median. So I count in from the top 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my median is 40. And this data happens to be bimodal. It has two modes. I have a mode of 40 and a mode of 41. One thing that we have left off on the stem and leaf plot is the key, and the key for this plot would say something like this: 1/0 equals 10. That shows that my 1 was in the 10th position and my 0 was in the 1's position. The next thing we're going to look at is the formula for mean of the data in a frequency distribution. In this case, classes become very, very important because we don't know exactly what the numbers were within that category. So we use the class mark. In this case, F sub I means the frequency of each class, and X sub I means the class mark for each class. And in the denominator, it means the total pieces of data. So we're still going to be working with adding up the data, dividing by the total pieces of data. Now, let's look at a chart and see what we can do with it. First thing is, I need to know the class marks because I don't know if any of these were 10s, 10.5s, 11s, 11.5s, 11.9s. So I need the class mark. So the first thing I would do is add 10 plus 12 and divide that by 2, and that answer would be 11. Now, once you know the class mark, and if you know the class intervals, which in this case we were counting by 2s, after you have the first class mark, you can simply add the class interval onto each piece. So the remaining class marks were 13, 15, 17, 19, and 21. My next column out that I added on to my frequency distribution is the class mark times the frequency. I simply did all of these multiplications, and these are the results. You may want to pause the podcast periodically and write them down. Now we're ready to finish the formula. The first thing is I need to know what all of the data totals up to, so I needed to sum up the final column. And if you sum up that last column, you get 508. The next thing I need to do is I need to add up the total number of my frequencies, which is 33. Now, that means we had 33 numbers, and all 33 numbers added up to a grand total of 508. This is still your typical mean formula. This part represents the sum of I equals 1 to n of the F sub i's times the X sub i's, or the sum of all my data. This number in our formula is the summation of I equals 1 to n of all the F sub i's, total number of pieces of data. Our mean is actually 508 divided by 33, or approximately 15.4 would be our mean. We will go over finding the median from a frequency distribution in class. This concludes your podcast for today.